Okay, we're looking at the second video on partial fractions, and we've only got 4 slides, but it still could take a bit of time. So in this particular case, the numerator, the degree of the numerator equals or is greater than the degree of the denominator. Okay, so first one, we've got x squared on the top and x squared on the bottom. So these are equal. So when you set this up, we're just going to break them up. Sorry, beg your pardon, x and x squared will go into x squared at least a whole number of times. So we have to have a whole number plus 2 fractions after that. And now that's a 2. Handwriting's bad. Okay, so the next line would be 3x squared plus 5x plus 7 is the same as a bracket x minus 1 x minus 2 plus b x minus 2 plus c x minus 1 x minus 1. Okay, so then let x equals 1 will kill a and c, and then subbing into there, just do my notes back, we've got 15 on the right hand side, and b is the only term that's left. 1 minus 2 is minus 1, so b equals minus 15. Let x equal 2 will kill a and b and leave c. Putting that into there, I get 29. A and b are dead, so we've got c left with 2 minus 1 is 1. So c equals 29. And then to get the last one, we've got no more substitution, so we just look for like terms. So I'm going to do the x squared term. So x squared is 3, is the front, and x times x is x squared, so it'll have a of them. And b and c can't generate x squared, so there's no plus, so we're done. A equals 3, and so the final integral would be 3 plus minus 15 over x minus 2 plus 29 over x minus 1 dx, and so 3 is 3x minus 50 equals log base e x minus 2 plus 29 log to base e x minus 1 plus c. Okay, and we're done. Come across when you're ready. Okay, so next one is a little bit harder. We've got x cubed on the bottom, x to the 4 on the top. So when x cubed goes into x4, we're going to have an x left over, and once you've got an x left over, there could be a whole number. So when we set it up this time, we have to allow for the fact that we've definitely got an x, and there could be a whole number b, and then we've got c over x minus 2. Now, because this one here has a squared, we have to allow for the fact that it could be this. So it's not going to be a whole number, it could be some part of an x as well. Okay, so the next line would be 2x4 minus 5x cubed minus 3x minus 1 equals ax plus b times x minus 2 and x squared plus 1 plus c times x squared plus 1 plus d x plus e times x minus 2. Okay, I'm thinking that this part here, we might have to do some practice on division to actually see what's happening there, but otherwise I'm just going to assume that you have done polynomial division before. Okay, so we're looking at a substitution. The only substitution we can do is x minus 2, which will kill off some of those numbers. So if I say let x equals 2, when I sub x equals 2 into there, you should get minus 15, and c times 5 is left, so gives you c equals minus 3. Now there's no more substitutions. You can't substitute anything to make x squared plus 1 go away, so now we just have to like terms it. So for the x4 term, there's 2 of them, and to get an x4 term, x times x squared is a to the 4, so that'd be a, and then c can only go as high as x squared, and dx and x can only go as high, so a equals 2 is the stop point. For the x cubed term, minus 5 equals, now c can't get to x cubed, de can't get to x cubed, but a and b can both get to x cubed, so ax times minus 2 times x squared would be a cubed term, so we've got minus 2a, and then b times x squared would also be a cubed term, so that's the only ones. And then equals minus 4 plus b, so b equals minus 1. Let's look at the x squared term, which so there's no x squared term, so there's nil, you can put that down. But we can actually use the x squared term because there's not one, so it's 0 equals. Now, can we get an x squared term out of the first bracket? We can, because ax times 1 would give us an ax squared. So ax times x is ax squared times 1, so that's just going to be plain old a. The b would be b times minus 2 times x squared, so that's minus 2b. Can the c give us an x squared? Yep, c times x, so it's just going to be c, and then plus d. And plus d. And we know these numbers already, so 0 equals a is 2, minus 2 times 1 is that's plus 2, c is minus 3, plus d, so d equals minus 1. 4 minus 3 is 1. Yep, that's right. Now to get the last one, we'll look at the constant. And the constant is minus 1. So minus 1 equals. So how do we get a constant? Well, we can't get a constant from the a term because we've got an x there. So b times minus 2 times 1 is minus 2b. The c times 1 is a constant. D can't give us a constant because it's got an x, but e times minus 2 will give us a constant. And then b is minus 1, so that gives us plus 2. C is minus 3, so minus 1. And when you solve that, you get minus 1 equals 2 minus 3 is minus 1 minus 2e, so e must be 0. And so our final answer, we've got the integral of 2x minus 1 minus 3 over x minus 2 plus minus x over x squared plus 1, because e was 0, dx. So 2x is just x squared, minus 1 is x, next one is log, and the derivative is 2x, so we have a multiple, so we have minus a half log x squared plus 1 plus c. Okay, and I think that might be the last one. Yep, so there's an exercise that'll be put onto Moodle. Okay, thanks, bye.